Hi there, this is your favorite non-Indian math channel and I have an infinite sum problem for you. So let's see how we can do it. So I have some stuff at denominator. It would be nice if I can simplify it, or even better ways, just if I can find like something recursive like 1 over n plus 1 minus 1 over n plus 2. For example, this sum is quite easy. Uh, but can I do that? So let's try to factor this nominator. Well, all of these signs are positive, so it's wise to just try negative numbers. So if I put 0, it doesn't work. If I put minus 1, let's call this thing an, okay? So a1, sorry, well, it's not officially not sequence, okay? Or let's say fn. So f minus 1, let's call this thing fn. F minus 1 is gonna be, so these are minuses, and so minus 12 minus, so this is gonna be minus 1. If I put minus 2, this is gonna be minus 8, this is gonna be minus 22, so it's minus 30, and this is gonna be just minus 29, so it's again minus 1. And if I try minus 3, minus 27, this is also 33, so it's minus 60, and this is gonna be minus 59, so this is also minus 1. Okay, well, this looks like a bummer, but it actually worked. Now look, so all of these are not roots, but if I had plus 6, all of these would be root. So actually I can write this fn, therefore I can just say fn. So I have n plus 1. If all of these were 0, I would just say fn is n plus 1, n plus 2, n plus 3, and I would be done. But all of these are equal to minus 1. So if I actually add 1 to it, this is not going to be the thing I want, because when I put minus 1, so this thing is going to be 0, but I want it to be minus 1. So I need to put minus here, and this is going to satisfy for all of them. And so since this is cubic, I only have 3 roots. Okay, cool. Well, I didn't officially find roots, but this seems kind of enough for me. So let's see what is my sum is going to look like. So my sum, let's write k terms instead of infinity to be able to work with it. Okay, it's not allowed to play with infinities like that. So I'm writing n is from 1 to k. So let's name this thing sk. I found that this thing is just k plus 1, k plus 2. Sorry, my index is n, so it should be n plus 1, n plus 2, n plus 3 minus 1 over this. Okay, so if I try to simplify it, well, if I separate it with just this minus, from the first part I will have all of these are canceling kinda. Let's rewrite this n plus 3 factorial. It's gonna be n factorial times n plus 1, n plus 2, n plus 3. So actually, yeah, they simplify a bit nice. We will see if it actually works. So if I write this, it's gonna be sum, n is from 1 to k, 1 over n factorial, and this thing is just gonna be minus, so this is just gonna be the same thing, and 1 over n factorial, or maybe I can just say n plus 3 factorial for this one, because now this actually makes sense, because so when I put 1, 2, 3, so when I put n is equal to 4 and 1 here, they're gonna be the same thing, okay? So it will cancel like at each third term. So let's see how would this look. So I'm writing them. So if I put 1, it's gonna be 1 over 1 factorial. I'm not gonna open them. Well, maybe this one I can open. 1. minus. Okay, so first let's just write all of the positive ones. So I have 1 over 2 factorial 2, then 1 over 3 factorial, 1 over 4 factorial. From here I won't open them, so it's just gonna go like this, 1 over 5 factorial. And negative ones are gonna be like, so I'm starting from 1 over 4 factorial. I will write it from this part because it's just gonna cancel. So let's put a plus parenthesis, there is nothing here. So this is gonna be 1 over 5 factorial. So it's gonna go like this, and all of these terms are just gonna be same. So except this thing is just shifted by 3. So in the end, well, let's write loss terms. So if, well, I actually don't really need to write them because it's obvious what's gonna happen to them. Let's write loss term, okay? Only loss term. So I have from k, it's gonna be 1 over k plus 3 factorial. I will actually have last 3 terms of this thing. The last 3 will cancel for this one too. Anything will cancel. But last 3 terms will stay here. But here, this infinite sum, as n goes from 1 to infinity, of my sum, let's write sum, this is equal to limit as n goes to infinity of sk. Sorry, so if I have it k, this is k goes to infinity sk. And so this is going to be equal to just if I take this limit, okay? I have few constants. Let's not care about them for now. Let's say these are a, add up to a. And I have last 3 terms of this thing. And they are just 1 over k plus 1 factorial, 2 factorial, 3 factorial. They're all just going to be 0, okay? So all of these are just going to be 0, plus 0, plus 0. Okay, so my answer is equal to this thing, which is, if I just add them, 6 plus 3, 9, 10 over 6, which is 5 over 3. And this is my answer.